Okay, number 11 is an arc length problem. And it might be useful to draw a picture here. We have y squared equals x cubed, and then the line x equals 4. So if I draw in the line x equals 4, it's here. Now, if I square root both sides, I'll have y equals the plus or minus square root of x to the 3 halves. I think we're going to get this thing that looks like a bird flying right here. So the question is, okay, hang on, I just hit pause and came back. It is a bird flying, but I put it in the wrong quadrant. So let me fix that. This is just our x-axis. The bird flying is partially here and partially here. And this is important because you want the arc length of this curve cut off by the line x equals 4. So it's this and this. So what we can actually do is just find the one arc length up here and double it. So this curve is y equals x to the 3 halves. And if I set up a situation where I'm integrating that from 0 to 4, and I double that integral in order to get this part and this part of the curve. So I then need 1 plus the derivative here squared. So the derivative of y is y prime, which will be 3 halves x to the 1 half. So when I square 3 halves, I get 9 fourths, and when I square x to the 1 half, I get x. And I end up with a pretty tricky integration problem. It's doable, but I'm going to need u substitution to do it. So I'm going to I'll work over here. My u is underneath my inside function, 1 plus 9 fourths x, and my du will just be 9 fourths dx. And I don't need that 9 fourths, so I end up multiplying by 4 ninths on the outside. So 4 ninths times 2 is 8 ninths here, and then I have the square root of u du. And then my limits of integration are going to change, or it looks like what I did in this work here is that I converted back with u substitution, which is fine. So I will integrate rad u. That's going to integrate, I have 8 ninths, and that integrates to u to the 3 halves times 2/3. So 2/3 u to the 3 halves. And I believe that's where I came in back over here. I said, let's switch it back to 1 plus 9 fourths x instead of u. And I have the 3 halves here. Here's my 2/3. Here's my 2, and here's my 4 ninths. And I got that 8 ninths by multiplying through, but this brings me right back, matches here. And then I plug in, and then I use my original limits of integration from 0 to 4. If I plug in 4, this nicely just goes to 9, so 1 plus 9 to the 3 halves. And then plug in 0, I get 1 to the 3 halves, which is right here. Notice that from this step to this step, I multiplied through the 2 times the 2/3 times the 4 ninths. And I got 4 times 4 is 16 over 27. That's right here. So then I end up with 16 over 27 times 10 to the 3 halves minus 1 to the 3 halves. So that's this. And it looks like that exactly matches choice C.